Now I want to talk about the domain and range of a graph that has one or more infinite parts. So let's just review before we move on. We know that the domain is the set of our x's. It's how we travel along the x-axis. I refer to it as the leftness and rightness of the graph. How far to the left does the graph travel? How far to the right does the graph travel? When we talk about the range, we're talking about the y coordinates. How low does the graph travel to how high does the graph travel? So when I look at my first graph and I want to determine the domain, think about how far to the left this graph must go. So it's going to go to x equals 1, x equals 0, x equals -1, x equals -2. Does it go any further than x equals -2? No, it doesn't. This is sort of the stopping point, if you will, along this line. Remember, this equation is x equals -2. So the leftmost point of my graph is at -2, and it's a closed circle, so we introduce a bracket. All right, how far to the right does this graph go? Well, x equals 1, x equals 2, 3, 4, 5, 6, 7. But see that arrow? That arrow says I'm going to go to 8, 9, 10, 11, and on forever. So this one's going to go to infinity. All right, now let's look at the range. How low does this graph go? What is my smallest y coordinate? Well, y equals 2, y equals 1, y equals 0. Let's go a little more. Y equals -3, y equals -4. But then it starts to crawl back up. So it looks like my lowest point is right here at y equals -4. And it actually touches the line y equals -4. So my lowest point is -4 inclusive. So now let's see how high this goes. Well, here we get to y equals 0, y equals 1, y equals 2, y equals 3, y equals 4, y equals 5, y equals 6, y equals 7, and forever. So the range caps, or it doesn't cap, it goes to infinity forever. All right, so that's how infinite graphs are a little different from the finite graphs that we previously did. Y'all ready? All right, challenge accepted. Let's look at our domain for problem number 2. Okay, how far to the left does this thing go? Well, x equals, pause a second. Notice here, we're numbering by 2s. That almost got me. So we're going to go x equals 6, x equals 4, x equals 2, x equals 0, x equals, there it is, x equals -2. And it's an open circle. No, a closed circle. My bad. Closed circle on -2. So we're going to use a bracket. So let's go in the opposite direction. How far to the right? X equals 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So this is going to go to infinity. And by the way, I had a teacher who actually wrote the endpoints of infinity and negative infinity on the graph so that you can say, well, anytime you're moving in that direction and you keep going, you're going to infinity. And anytime you move in that direction and you keep going, you are heading to negative infinity. So I think I'm going to do that here. So now when we talk about the range, let me include those points as well. Up here, if you keep going up forever, you tend towards infinity. If you keep going down forever, you tend towards negative infinity. So let's use that information to help us with our range. Our range asks us to go from the lowest point, which is across this line here. So that's where y equals 1, and it's a closed circle. So we're going to go up to y equals 4. We go back down to y equals 1. Then we go to y equals 4, 5, 6, 7, 8, forever. Okay? So just to throw back a little, this is a high point, but it's not the highest point. Remember, that's the relative max. That's a relative max within here, but then this graph goes to a relative min, and then it goes up for forever. All right, so that's kind of everything we need to know. And now we're going to spend the next several minutes just reviewing some of these. And this sheet not only includes infinite graphs, but notice our scales are kind of messed up. So you really do have to pay attention. Okay, so here we go. For my domain, how far to the left does this thing go? Well, it's going to negative 32, and as it goes out, it's going to go to negative 36, negative 40, and so on. So my domain goes to negative infinity. You know, I almost wrote like a number there. Whoa. Okay, so how far to the right does it go? Well, let's trace it. We're going to x equals negative 20, x equals negative 16, x equals negative 8, x equals negative 4, x equals 0, and we stop here at x equals 4. And we see that it's an open circle, so we have our right parenthesis. Now let's talk about range. And so what I'm going to do is what I just did for that point. I'm going to trace this graph or hover over it. So look what happens, and I'm just going to count my y coordinates. So here my y coordinate is negative 10, negative 12, negative 14, negative 16, and then it stops. It stops right here at y equals negative 16. So we have negative 16, and since it's an open circle, we have a left parenthesis. All right, so now let's trace the graph the other way to see how far up we go. So we're going to go negative 16, y equals negative 14, y equals negative 12, y equals negative 8, y equals 0. But look, it keeps going. So y equals 2, y equals 4, y equals 6. We're heading towards infinity. Remember, we go up to infinity, down to negative infinity. All right, so hopefully you're feeling pretty good about yourself, because I am. Because I'm understanding this. All right, number 4. That's a beautiful graph. Let's see how far to the left it goes, how far to the right it goes. Well, if you look at this one, see how this is going forever that way? It's going forever to negative infinity, remember? All right, how far to this? So we're going to trace a little. How far to the right does this go? Well, that's going that way forever. So it's going to positive infinity. And bonus points here, this thing is not a function because it fails the vertical line test. Look right here. It touches here and here and here 3 times. It's not a function, but nonetheless, it's a beautiful graph of a relation. But I digress. All right, let's go on. For the range, how low does this graph go? Well, it's going to go down. It gets to negative 21, and then it'll get to negative 24, negative 27, negative 30. So it looks like it's going to go forever down. So it'll go to negative infinity. How high does this thing go? Well, it's going to go to 2, 3, 6. Eventually it'll go to 9. Eventually it'll go to 12. I'm sorry. So it goes 3, goes up to 6. It'll go up to 9 and so on. It just kind of keeps going. So it goes up to positive infinity. Okay. So these are the directions that we go. Now let's look at number 5. All right. So this is my graph to find the domain. Let me put my little reminders. I keep forgetting to put these. I keep reminding myself to put my reminders. All right, how far to the left does this graph go? Well, it's going to go to x equals 0, x equals negative 2, x equals negative 4, x equals negative 5, x equals negative something, and more negative somethings. So it looks like it's going to negative infinity. We never touch infinity. It's an open circle. Well, so we have a parenthesis. How far to the right do we go? Well, here's where x equals 0, x equals 1, x equals 2, x equals 3. We stop right here. And it's an open circle, therefore I put a parenthesis. All right, for the range, how low does this thing go? Well, let's count or mark our y coordinates. Here, y is 16. Here, y is 12. Y is 8. Y is 4. Y is 0. Y is -4. Y is -8, -12, negative something, negative something, negative something. So my lower bound on my range is negative infinity. So now let's go backwards. How high does this go? Well, y is 1. Just kidding. Y is 4. Y is 8. Y is 12. Y is 16. Does it go any greater than y equals 16? No, it doesn't. So we put our parenthesis there. And there it is. Okay. Moving along swimmingly. Let's look at number 6. So remind myself about what the infinities look like. All right, so my domain. How far to the left does this graph go? Well, here's x equals 0, x equals -1, x equals -2, x equals -3, x equals -4. It doesn't go any further to the left than -4, and it touches -4. So we put a bracket there. How far to the right does this go? Well, here x equals 0, x equals 1, x equals 2, x equals 3, x equals 4, x equals 5, and so on, because there's an arrow. So we know that this thing will go to infinity. Okay, and I failed to do this one earlier. I will fix that. This goes to negative infinity. This piece of the y-axis goes to positive. Okay, how low does this graph go? Well, let's start just here because it's a nice starting point. Here, y equals -2, y equals -3, y equals -4, y equals -5, y equals -6, -7, -8, -9, negative forever. So we are going to negative infinity. We never touch negative infinity, so we get a parenthesis. Now, how high does this graph go? Well, here y equals -2, y equals 1, y equals 0, y equals, oh, that was a -1, my bad. Y equals 0, y equals 1, y equals 2 is the highest that this thing goes. And do we touch the 2? Yup. So we have a bracket there. Okay, think about it. You know, what I'm saying here is my end line right here is y equals 2. I mean, didn't we say that's the equation of a horizontal line is y equals 2? So that's going to be part of our bound for our interval. Right, number 7. Let's look at this one. Okay, let me remember my infinities. All right. So the starting point, the leftmost point of this graph occurs right here where x equals 3. And it is an open circle. So we have a parenthesis and not -3, just 3. Good cover there, Robadeer. All right. How far to the right does it go? Well, it's going to x equals 4, x equals 5, x equals 6, x equals 7, x equals 8. The arrow says go to x equals 9, go to x equals 10, 11, and 12. Yeah, it goes forever. So my domain is 3 to infinity, excluding the endpoints. How's that for vocab? All right, now let's look at my range. My range is down here at negative infinity. Oh, just kidding. I'm labeling my my axis to go to negative infinity and positive infinity. My bad. I totally did not mean that. All right, so now that we've established that I screwed that up, let's see what I can do to fix it, okay? Okay. How low does this graph go? Well, here, y equals 8. Here, my y coordinate is 6. Here, my y coordinate is 4. And do I touch that 4? No, I don't, because it's an open circle. So I put a parenthesis. Now let's see my greatest y coordinate, and that'll give me the endpoint for my range. Y equals 6, y equals 8, y equals 10, y equals 12, y equals 13, 14, 15, 16. It goes on forever to infinity. Okay, so let's see how the next one goes for us. Let me start with my little cheat points here. Okay, how far to the left does this graph go? Here we're at x equals negative 20, x equals negative 25, x equals negative 30, x equals negative 35. Oh, x equals negative 40. And it's a closed circle, so we introduce a bracket. Now let's see how far to the right this thing is going to go. So we'll go to x equals negative 10, x equals negative 5, x equals 0, x equals 5, x equals 10, x equals 15, x equals 20, x equals 30. It keeps going to the right, so it's going to positive infinity. And remember, you can never touch infinity, so it always has a parenthesis. So let's label the extreme values on my y-axis. And now let's look at those. My range. How low does this thing go? Well, here it's going to y equals negative 5. Here my y coordinate is negative 6, but or negative 5. This says keep going, so my y coordinate here is negative 6, negative 7, negative 8. So it's going to go to negative infinity. And notice, even though this is still going down, it's still going to the right. So going to the right forever goes to infinity on the domain. Going down forever goes to negative infinity on the range. So remember, this arrow has two meanings. You have to consider both directions. Okay, so how high does this thing go? Well, here my y coordinate is negative 5. Here my y coordinate is negative 3. Here my y coordinate is 2. And then it actually starts to turn back down to a y coordinate of negative 3 and negative 4. So it looks like this is my maximum area. And that's where y equals negative 2. And guess what? We're touching that line. So it gets a bracket. Okay, last one. Oh my gosh, this one's super fun. I love this one. Okay, so domain, remember, concerns our x coordinates. What is my leftmost point? Well, I've got x equals 6. What is my rightmost point? Well, it looks like all of my x coordinates are 6. So guess what my domain is? I'm not going to use brackets or parentheses. It's just the element 6. Remember, at the very beginning of functions, we said the domain is the set of your x coordinates. So I have to put this in braces to indicate that it's a set. Okay? So my domain is only 6. Think about it. You've got 6, 15, 6, 10, 6, 5, 6, 0. I mean, not to mention the points in between 6, 7.5, 6, negative 12.5, 6, negative 25, 6, negative 30. I keep saying 6 over and over as my x coordinate. There it is. All right. So now for my range. How low does this thing go and how high does this thing go? Well, My y-coordinates are -10, -25, -30. This says keep going further negative, further negative. So I'm going to negative infinity. But how high does this graph go? Well, we're going to go up here. We go up to y equals 5, y equals 10, y equals 15. And do we include the 15? Well, that open circle says we do not. So therefore, we put a left parenthesis. I love number 9 because it shows you the domain can be a set or an element, but it can also have a range of values, a collection of values. And that's how it is. Okay? So domain, remember, is the set of your possible x coordinates. How far you travel to the left, how far do you travel to the right? The range is the set of your y coordinates, your possible y coordinates. How far down does the graph go? And then how far up does the graph go? And that's what you're going to do to find domain and range. Look for the arrow because the arrow indicates this is going to go to infinity or negative infinity, as the case may be. But that's sort of everything you need to know about domain and range. And this worksheet was brought to you courtesy of mathworksheetsforkids.com. They're my other go-to when I need a sheet for something to do. Okay? So that's domain and range of graphs that have an infinite part or, an infinite graph. So there it is.